This video is about the difference between ceramic and glass crystal structure compared to other crystal structures. So we looked at crystal structures in general, and you saw that materials that are crystalline are materials that have a regular repeating structure of their atoms. Oftentimes that's described as being in kind of a lattice or a 3D network of atom cores. And then we think those atom cores are surrounded by these electron clouds, and we roughly represent them in drawings as spheres. So on page 62 of the Ashby book, you'll see that there's an example of one of these sort of drawings of two ceramic materials. And what this shows is that ceramic materials, especially high-tech ceramics, which are shown here, this is tungsten carbide on the left and then silicon carbide on the right, they often form in these types of crystal structures like the metals, except you have different types of atoms that are occupying the unit cell. And oftentimes the bonding that you have in these ceramics are either ionic bonding or covalent bonding, or some sort of mixture between those two, ionic and covalent, a mixed version. So these are sort of high-tech ceramics in a crystalline structure, and glasses, which are in the same family as ceramics. If you go to page 63, you can see that they have a different structure, and this is the top view in figure 414 of glass, what glass looks like. In glass, it turns out these larger green circles are representing the oxygen atoms, and the smaller one at the center is representing the silicon atom. And this isn't exactly right, because this is actually trying to show you a tetrahedron, which means that you have maybe three silicon atoms, and then, three oxygen atoms and another oxygen on top, and the silicon is in the center. So what you're seeing this top view of is looking down on this tetrahedron, where you see these three atoms like this, the silicon in the center. And they're connected on these corners. And in the glass, what happens is the oxygen atoms connect on these corners in sort of this network. Sometimes it forms a plane, sometimes it's in 3 dimensions, and sometimes it's sort of broken up by especially adding other atoms like soda or sodium or lime, like soda-lime glass. And what that does is it breaks up this network structure and makes it easier to deform the glass, this whole structure, at lower temperatures. So a lot of times that's what additives to glass do, is actually alter this 3-dimensional network of silicate molecules.